Hello guys, our next topic is equivalence of states. Okay, so we'll take the same example as we have taken it in equivalence of finite automata. Okay, so this is the finite automata. These two are equivalent finite automatas. Okay, so and here we have written transition table for these two. So left hand side symbols will represent related to this finite automata and right hand side symbols will represent related to this finite automata. Okay. Now we will observe one thing, that is I have written here q1, q2, q3 and again I have written here q2, and in case of this finite automata q4, q5, q6, q7. Okay, so as we have discussed already in equivalence of finite automata, these two finite automata accept the same set of strings. Okay, so if we observe that here we have three states, okay, and here we have four states. Okay, so and we go much in detail, then we will observe one thing, that here q5 and q7 will work same as the state q2 that is present in this first finite automata. Okay, so means there is no need of these two states to be different. Okay, so if we minimize the finite automata, then that will look like this first finite automata. Okay, means what work is doing the state q2, that work is divided and that is done by these two different states. Okay, so if we remove some of the transitions and if we minimize the transitions and states from this finite automata, then this finite automata will be converted into this finite automata. Okay, so when we can convert or we can minimize the finite automata, if we have equivalent states. Okay, so equivalent states means what? If we supply 0 input to state q2, then it will go to state q3. q3 is my non-final state, and again if we supply 0 input to state q5, then it will go to state q6, and q6 is again our non-final state. Okay, so same is the case related to this one input. So if we supply q2, if we supply one input to state q2, then it will go to state q1, that is final state, and here is the same case, that is we are going to state q4. Okay, so q4 is again final state. Okay, means, and again now we'll supply 0 input to state q2, then it will go to state q3, and 0 input to state q7, that it is going to state q6. Okay, means what, here we observe we have the same transitions repeated in case of q5 and q7. Hence there is no need to have these two states as different states. Okay, means these two states are equivalent. Okay, so if we observe again the same set of strings, okay, so the path they are moving from initial to final state. Okay, so they are reaching to final state, even though we have large number of states or one state extra than this, then it will work same as this. Okay, so here q5 and q7, these two are equivalent states because they perform the same task that should be done by the state present in first finite automata, and that state is q2. Okay, so means we don't need two different states performing the same tasks. Okay, so these two states are equivalent states. In case of minimization of finite automata, we have to observe the equivalent states. Okay, also one more point is related to these two, when we can say that one state is equivalent to other, if we have the same state, that is one state is final and other is also final, or one state is final, non-final and other is non-final, then and then only we can say that these two states are equivalent. Okay, so we cannot say that two states are equivalent if one state is final and other state is non-final, because one state is final, then any string reaching to that state, that will be accepted by that finite automata, and if state is non-final, then it is not possible to accept that string after reaching to that state. Okay, so final non-final states cannot be equivalent at all. Okay, so if you have any queries related to this, then please comment on it. And if you like my videos, then never forget to like, share and subscribe to my channel. Thank you very much.